All right, welcome back to Intro to Statistics. So we are talking about 9.1, hypothesis testing and how to get through these. So here we have hypothesis, mu is equal to 6 versus mu is not equal to 6. So it's a two-sided test. So what we're going to do, we go ahead and draw our little pictures here. I recommend that you do this. You don't have to because your test is going to look a lot like this. Okay, but I would have a little piece of scrap paper here. Okay, we have 6, and what we have here is we have our normal distribution that's going through here, and it's equal 6 or not equal 6. So we have a two-sided test. It could be this side or that side. We have is our z statistic is 2.27. So here we have negative 2.27, or we have a positive 2.27 here. What we're doing is we're finding this area here. We need both of them because it's a two-sided test. So it'll give you this side or that side. So how do we do this in a calculator? Okay, so we're going to go to our calculators and we're going to hit, there's a couple of ways we could do this, okay? What I'm going to do is I'm going to show you, say, hey, you know what? I want everything except for the stuff that is between, let's pick a different color that's reasonable. Okay, I want everything except for the stuff that is between these two spots. What's another way to do that rather than calculate this area and calculate that area? What we can do is we can say, you know what? 1 minus norm CDF between the negative 2.27, positive 2.27. The hardest part about this chapter is actually coming up with, like, remembering that if it's a two-sided test, you got to include this part and that part, okay? So if we take 1 minus the edges here, okay, so we're pretty much taking the middle slice here and we're getting rid of this part. So we're going to say, okay, well, how do I do that? It's been a while. So we're going to go back here. We're going to say 1, it's just 1, not 11, 1 minus. We're going to go to distribution here. Okay, and we always do normal CDF. Okay, it's always the collective amount. Okay, and remember it's going to be between negative, don't pick minus, I pick that one, 2.27 up to 0.27, 2.27. And then what's my biggest value? My biggest value is positive 2.27. Okay, so the reason I'm doing it this way is because we don't need to deal with big numbers or little numbers. We used Z. Z is always the standard normal. So if they use Z, we know it's normal. Mean is equal to 0. Standard deviation is equal to 1. Okay. If they use X, then we have to type in the mean and the standard deviation. But they use Z, so we're going to be able to say, okay, well, we have big number or small number, big number, and then my average, my mean is going to be 0. The standard deviation is going to be 1. Right? So in here, I end up with 0.0232. So this is 0.0232 here. Okay, so my p-value 0.0232. Okay, so that's nice. So we'll go ahead and hit that one. All right, here we go. So we'll check. All right, hooray. Z statistic is negative 1.39. Okay, so in this case, let's see here. I think because it's a two-sided test, we still need to go with both sides. So even though it says we have a positive number here or a negative number here, because it's a two-sided test, we're really dealing with like both the positive and the negative. Okay, if we had a left-sided or a right-sided, we have a slightly different picture. But because we have that, we still want the what's going on. Here's 1.13 or here 1.39, negative 1.39. But because it's two-sided, we also want this side. So we need both of these to be in here. Okay, so that's what we're going to do. So we're going to say this is going to be 1 minus, and again, distribution CDF. Okay, what's our low number? It was negative 1.39 in this case, negative 1.39 to positive 1.39, and our average 0, standard deviation 1. Enter. We'll have that. This case is 0.145. Okay, so 0.1645. 645. Okay, so that would be a do not reject. Okay. If we have to know that, we don't know what alpha is, so they're just asking us to calculate probability values right now, just p-values. Okay, which provides the stronger evidence against HO. All right, when I went to school, they warned us about this. So just because you have a lower probability doesn't really mean you're stronger evidence. You're just saying it's this or that. Okay, we don't really rate this. I hate the fact that this book does it, but since it does, and they're the boss, and that's how we're going to get our points, we're going to go ahead and play ball with them. But I really do warn you that just because you have a lower p-value doesn't necessarily mean it's more or less. Okay, we're just looking for, did it meet the cutoff or not? That's all we care about. They didn't provide us one, so we're going to play by a slightly different set of rules. And we'll say, well, this has a lower probability of happening, so this is a stronger evidence. Okay, so if we're going to say reject the null hypothesis, right? There's a 0.02% chance that the null hypothesis is true. There's 0.16 probability that's going to be false. Okay, so rejection region is smaller region, so this is going to provide stronger evidence. Okay, I have no idea that this hurts. Okay, so z equals. But I would urge you not to do the way that they're thinking about it this way. Okay, a lot of people, that's not actually the way it works. Okay, once you've met the cutoff, you've met the cutoff. We don't say, well, we've met the cutoff by this much. Like sometimes, like, hey, look, if you're running a race and you come in first, does it matter if you beat the person that came in second by 0.1 seconds or by an hour? Doesn't matter. You still came in first. Okay, so you still got your trophy, you still got your win, you still proved your point. It doesn't matter by how much. Okay, so that's what we'll do with that one. So I'll let you go with that one. I am against doing part 3 here, but this first 2 are not too bad of a problem, so I wouldn't feel too bad about this problem. But if it's a face-to-face class, I can't selectively strip out parts. I don't know how to do that. I can't take away those parts. So we'll let this question stand. So generally, like the smaller the probability, the more evidence it gets, the null hypothesis. Okay. So remember, going back to Love Canal, right? The company is going to say, look, it's random chance. So, it's only 0.02, it's 0.145. It's like 15% chance that this happened versus it's a 2% chance that this happened. Say that, okay. But in reality, like we don't rank them that way. We just say once it's fallen below the threshold, it's fallen below the threshold. We don't really care by how much. Okay. So I'll let you go with that, and I'll see you in the next video. Thank you.